USB power adapter sent to me by a Swedish company called KS-Elektronikdesign. The adapter is called USBpwrME. This power adapter is in its final stages of development. You can follow its progress on the crowd supply page, which I'll link in the video description below. That way, you will be among the first to know when it becomes available. According to the product page, the adapter is designed to allow you to power any USB device directly from your bench power supply, and it has many safety features built in, which we'll take a look shortly. The board is actually very cleverly designed. It has these integrated banana plugs you can see here, so you can plug this board directly into your power supply. And if you look carefully here, you can see that the spacing of these banana plugs are actually adjustable. According to the specs, you can adjust the spacing of the banana plugs between 19mm and 23mm. This should accommodate most of the power supplies. Now, the standard spacing should be 3/4 of an inch, which is roughly 19mm. So let me show you the spacing here. Here's a ruler, and you can see here, right now the spacing is roughly 19mm, but of course, you have the ability to adjust. If you wanted to move this further, for example, you have the ability to adjust by roughly 5 or 6mm. Some of the cheap Chinese power supplies are known not to follow this standard spacing, 3/4 of an inch, and that includes a few power supplies I have reviewed on this channel. Let me bring in one and show you. For example, here is a 1-tap power supply that I have reviewed on the channel. And if you take a look, let me try to make sure it's in focus. The spacing here actually is a little bit wider. So let's take a look here. And you can see from this edge to this edge is roughly 21 or 22mm. So clearly that's not the standard spacing. And if you don't have this adjustable banana plugs, you won't be able to plug in to a power supply like this. So this design, in my opinion, is very clever. To adjust the spacing here, all you need to do is just loosen the screw, and then you can push the side out by the desired amount. Very neat. I like the flexibility here. Now let's briefly take a look at the specs here. This board supports input voltages between 3 volts and 20 volts, as you can see here, and can be put in either negotiated output mode or pass-through mode via a switch at the bottom here. The USB-C device negotiation is controlled by a TUSB 319-Q1 DFP chip, which is a downstream facing port controller. And let's take a look at what else. And you can see here, the power output from this board is actually quite modest. In negotiated mode, it can output 10 watts from the USB-A port and 15 watts from the USB-C port. In pass-through mode, you can draw up to 25 watts from the USB-A port and up to 35 watts from the USB-C port. So that's pretty much the specs of this board. Let me plug it into a power supply and we'll take a look at how it works. For the power supply, I'm going to use this IPS 3608 from Finersi. I reviewed this power supply a while ago, and I will leave a link in the video description below. If you are interested, you can check it out later. Alright, let's actually take a look at the protected mode first. And that mode is actually controlled by this switch. I zoomed it in so you can see it better. And currently is on. When you put this in the on position, it goes through this protected mode. And if you turn it off, it goes through this pass-through mode. So let's actually leave it on here for the time being. And now let me plug it in. And you can immediately see we have 2 lights lighting up. One light is indicating that we have input power. The other one means we're in this negotiated mode. In this negotiated mode, the maximum output voltage from the adapter via these USB ports are limited because this board does not have an onboard DC to DC converter built in. The way it works is that if the power supply voltage is within the acceptable range, then the output would be enabled. Otherwise, the output would be disabled. Let me actually demonstrate. Now, for the demonstration, let me actually plug in this power meter to the USB-A port, and we'll see.
Trygg att aldrig sluta leka. Trygg med Sveriges populäraste barnförsäkring. Trygg Hansa.
Let me adjust the angle a little bit. Well, it's flickering a little bit. I try to adjust the shutter speed. Of course, that will change the brightness of the video. But anyway, so I think right now it's a good compromise. And you can probably see right now we're outputting roughly 5 volts. And here is display. I know it's a little bit hard to see, but it's 5.08. And what is on the power supply, you can see is 510. So let me actually increase the voltage on the power supply and we'll see what the behavior is. So let's come here. And let's increase 0.1 volt at a time. So if I increase it higher, right now it's 5.5, 5.6, and you can see after about 5.7, the output power was actually turned off for this output port. That's because right now we're in this negotiated mode, and the output is actually being protected. So let's try it again. Let's go down. 0.7, you can see now we actually have the output, and it's measuring 0.7. The voltage would be exactly the same as the power supply output because there's no DC to DC conversion on this board. So 6, 5, let's go down and see at what point actually we cut out. So 4.9, 8. So keep going down. And 3.6, 3.5, 3.4, 3.3, 3.2. Now this is interesting because you can see here the over voltage actually turned on. But right now you can see that we're actually not over voltage. We're at 3.1 volt. So let's keep going down. And by the look of it, we can go quite a bit down actually. 2.4, 2.3, 2.2, and of course we still have some output power, but I think that this power meter cannot operate at this low voltage anymore. So let's do it again. Now let's ramp up the voltage. As you can see that as soon as the input exceeds about 2.5 volts, the output is turned on, and let's keep increasing. And roughly above 5.6 volts, the output is cut off. Basically, in this negotiated mode, you are only going to get output when the input voltage is within range, and that's a safety feature. So that's the negotiated mode. Now let me actually flip the switch to the off position, and the board will change to pass-through mode. And as the name suggests, it will essentially pass the input voltage directly to the output without any protection. In this mode, I think the over voltage light is always on because that's just to warn you that you're currently in a different mode. You know what, let me actually unplug this power meter and let's plug into the USB-C port because we have already seen that with the USB-A port. So now you can see the output is 5 volts and as shown on the screen here. So let's actually turn it up. I'm just going to do 1 volt at a time. So let's do 10 volts, 11 volts, and you can see that the output voltage matches the input voltage. There's no surprise there. Right now we're outputting 11 volts. And let's keep increasing. Remember, the maximum is 20, so let's just go directly to 20 volts. And now we're outputting 20 volts. And again, you can see that we're also measuring 20 volts. Now I'm actually curious what the behavior would be for the USB-A port in this pass-through mode. Let's actually verify that. Alright, I just swapped in a multimeter because I think it's easier for you to see. And what I'm doing is I'm just using some paired wires to measure the USB voltage. And you can see here is the measured output. That is actually interesting because it appears that the USB-A port also passes the input voltage straight through. And that could be a problem if you are not paying attention to the switch position and the over voltage warning light on the board. Because most of the USB-A devices can't really tolerate voltages much higher than 5 volts. Now I suppose if you have a quick charge compatible port, it could potentially withstand 20 volts. But the majority of USB-As are 5 volts only. So this definitely could be a problem if you're not careful. And let me just verify indeed if we can change the voltage here. So let's go back to the voltage. Here you can see that there is no surprise. we're essentially just passing through. Now, of course, this pass-through mode can come in handy if you are powering a, let's say, soldering iron. So now let's actually try to connect the soldering iron to that. And let's take a look. So I'm going to connect to the USB-C port. Yeah, you can see the measured voltage is 19.8 volts. So let's turn it on. And of course, we're drawing power directly from the power supply. No problem. And let's actually adjust the output voltage here. Let's bring it down. 10 volts. And you can see we're showing 10 volts here too. And let's do 11, 12. Yeah, so essentially it is powered directly from the power supply. So let's go back to 20 volts. And not sure how well it shows up, but right now it's 17.8 volts. And now it's 20 volts. Now, I would strongly discourage using the pass-through mode, as it can be actually quite dangerous, because if you hook up a power PD compatible device, you will not be able to negotiate the input voltage, and that could potentially cause damage to your connected device, depends on how it is implemented. One last thing I want to show you is that this board does have reverse polarity protection. Now, I saved that test till the end, just in case something goes wrong. So let me actually dial down the voltage first, and we will try to plug it in the other way around. So let's do 5 volts. Okay, so no problem. Let's actually try to connect it backwards. All right, so now you can see here, positive is negative, negative is positive. And let's try to plug it in. Yeah, as expected, the output is 0. And let me increase the output voltage to the spec 20 volts and see what happens. So now it's 20 volts and we don't have any output. So it does seem the reverse polarity protection is working. Now the question is, did the board survive? So let's unplug it and plug it in again. Yep. And you can see that it survived. The reverse polarity protection worked exactly as advertised. I think this board will be open sourced once it goes on sale. Right now I don't have the schematics, but if you take a look at here, we have 3 of these 8-pin devices, and these are marked as 4177P, and these are P-channel MOSFETs. They're used to switch the output on and off. And you can probably just see this tiny chip, and that chip here is the TUSB319-Q1 DFP. So what's my verdict of this tiny USBpwrME adapter? Well, it's certainly versatile, and you can use it to power many USB devices from your bench power supply. Now, there are some limitations, and you do need to be very careful in pass-through mode, as the output voltage is exactly what you put in. This adapter, in my opinion, would be even more useful if it can incorporate a power PD chip, so that the USB-C voltages across the range can also be auto-negotiated. I hope you enjoyed the video. If you liked it, please remember to give it a big thumbs up, and don't forget to subscribe to this channel for more videos like this in the future. If you wanted to further support my work, please consider joining the channel and becoming a member. Your participation makes videos like this possible. Thanks for watching, and I'll see you next time.